Last lesson, we looked at simplifying algebraic terms like the one above using index laws. Just to recap, when we've got something like this, we do numbers first, so we look at the coefficients. We've got a coefficient of 5 here, a coefficient of 9 here, 5 multiplied by 9, 45. Then let's look at the x's. You've got x cubed multiplied by x, remembering if there's no power, it's being raised to the power of 1. X to the power of 4, and then y to the power of 5 multiplied by y to the power of 8, y to the power of 13. Hopefully you remember how to do that. If that looks unfamiliar, go back and watch the previous video. What we're looking at today is something slightly different. What if you were asked to simplify something that looks like this? What does this even mean? What this means is that everything in the bracket is raised to the third power, as in it's cubed. So what that means is it's x to the power of 7 multiplied by x to the power of 7 multiplied by x to the power of 7. So it is x to the power of 7 cubed. And using our index laws from last time, we can just add these to get x to the power of 21. Okay, so have a look at what we've just noticed. How could you have got 21 straight away without doing this method? Hopefully you can see that you could have just multiplied the 7 and the 3. So it's x to the power of 7 times 3, which is x to the power of 21. Does that always work? Let's say we were looking at 5 lots of x to the 7 cubed. What does that mean? It means 5x to the 7 times 5x to the 7 times 5x to the 7. If we look at the coefficients, we've got 5 multiplied by 5, 25, multiplied by 5 is 125, x to the power of 21. So we can do the x's in the same way. We can do 7 times 3, that's fine. But what about this 125? Where did that come from? Well, that came from doing 5 multiplied by 5 multiplied by 5. That is 5 raised to the power of 3. That is 5 cubed, which is 125. So you need to be careful when you're doing these that you don't just do 5 times 3 and end up with 15 there, because that would be wrong. You should end up with 125. Let's look at another example. Let's say you're asked to do 3x squared y 5 all to the power of 4. Well, you might be able to guess what you think it is. Let's have a think. Well, we're going to have something x's with a number, y's with a number here, and you're also going to have a coefficient here. Well, let's guess 2 multiplied by 4, that would be 8. For y, we'd have 5 multiplied by 4, that would be 20. What about my coefficient? Would I do 3 multiplied by 4? Would I do 3 to the power of 4? Let's have a look. So remember, this means 3x squared y to the 5, that's everything inside the bracket. I'm multiplying it by itself, so 3x squared y to the 5 times 3x squared y to the 5 times 3x squared y to the 5. If we look at all the coefficients, 3 times 3, 9, times 3, 27, times 3, 81. X squared times x squared times x squared times x squared. So we add those powers, you get 8. Y to the 5 times y to the 5 times y to the 5 times y to the 5 is y to the 20. So we were right with this, that you can just multiply out the powers. But the really important thing here is that this is 3 to the power of 4. So with the coefficient, you need to raise it to the power of 4, or you can use this method, which will help you avoid any errors. Well, minimize the errors at least.